All right, guys, so we've been talking a little bit about complex numbers. And one of the things that I want to do is I want to focus in on at least a few simple yet very useful relationships. Right, so this is a discussion on complex numbers. Some useful relations. And in particular, what I really want to take a look at is the Cartesian and polar representation of four numbers. The first is the number 1. The next is the number j. The next is the number -1. And the last is the number -j, like this. Right? Now, all of this is really going to hinge upon two things. The first one is remember that when it comes to a complex number, it can be rewritten in Cartesian form like this, or it can be rewritten in polar form like that, right? Now, suppose that we actually go to the complex plane, right? So in the complex plane, the vertical axis is the imaginary axis of our complex number z, while the horizontal axis is the real part. Notice that for the very first number, and I'll do this in red, number 1, this is already in Cartesian form, right? So if I really take a look at the number 1, this is already in Cartesian, right? Now, this number also happens to be located right there, right? Where this is 1 unit away from the origin. Now, notice that there is also a magnitude that this actually has, right? So if I start at 0 and I go all the way out to 1, right, I've traveled a distance of 1. And from the positive real axis, notice that I've traveled through an angle of 0. So equivalently, this same number can be rewritten as 1 e to the j 0 degrees, or in our notation, this is 1 angle 0 degrees. Being able to go back and forth between the Cartesian form and the polar form is going to be extremely useful. The second number I want to take a look at is the number j, right? J itself happens to be up here. So this is the number j. And this is already in Cartesian form, right? So here, j, if I really, really wanted to be technical, this is 0 plus 1 times j, like this. So you can really explicitly see that it is in Cartesian form. In polar form, right, notice that if I start at the origin and I go up to this number, I've traveled a distance of 1, right? And I've gone, and I'll do this in green, from this axis over to this one, I've gone an angle of 90 degrees. Right? So this same number can equivalently be rewritten as 1 times e to the j, and the angle here is 90 degrees like this, or just e to the j90, or lastly, this is also 1 angle 90 like this. Right? So again, notice that even the simple number j has multiple useful forms in which it can actually be written. We can play the same game for the number -1. -1 is located over here, right? So here, -1 can also be rewritten as -1 plus 0 times j. And in polar form, notice that the distance from the origin out to there is 1. That's the distance. And I have traveled from the positive x-axis to this location. I've gone through 180 degrees that way. Or if I wanted to circle back the opposite way, that'd be -180 degrees. So this number in polar form is 1 e to the j 180 degrees, or just e to the j 180, or lastly, this is 1 angle 180 like this. Any one of these forms may appear in your calculations, and it's good to be able to recognize what those are. The last number that we want to really kind of focus in on is the number -j. And you can see that the analysis is going to carry over just as well. So here we actually have -j like this. This can be rewritten as 0 plus -1 times j. This is Cartesian form, or just 0 minus j. That number happens to be located right here in this quadrant. Notice that the distance from the center down to that number